We're going to be talking about direct variation, which is just another way of saying that you've got a proportional relationship. Something that you'll notice with direct variation, it's just a special type of slope-intercept form. It's still just a line. It's just a special type of y equals mx plus b. The only thing is that, yes, it's line, but it has to go through the origin, which is 0, 0. And then this origin right here, the 0, 0, proportional, the word itself actually reminds you that it's going through the origin, which is 0, 0. Now, when we've got it going through the origin right here, you have to make sure that you're not including the b value, because at this point, your b value, when it's crossing the origin, is 0. So your slope is very, yeah, it's happy that the b is there. But when the b is at 0, it zeroes out right here, and your slope right here ends up being identified as k as well, because it's just like, k. Your best friend's not there. So your slope just becomes very mellow. It's kind of like saying I have $5 plus $0. I don't say I have $5 plus $0. I just say I have $5. And when you've got this set up as a direct variation, your slope right here can be referred to as two other phrases. You've got the constant of proportionality and the constant of variation. And these both come from the name of the relationship of itself. It's a direct variation. It's a proportional relationship. When you see it in problems, you're going to see it a couple of different ways. And we're going to look at 1a first. 1b is a different type of problem. You're going to see that y varies directly as x when y is 72 and x is 8. For part A, it's asking us to find an equation for this direct variation. Again, you want to remember this equation. This is not in your formula chart. You have to know it, or you have to know that it comes at least from y equals mx plus b, and that your b is just zeroed out. What we're going to end up doing is we're going to plug in our x and y values right here. Our x value of 8, and our y is 72, and we're going to drop these in so that we can go ahead and solve for k, so we can figure out what that k value is and write our equation. Using our inverse operations, we've divided by 8, and you get that your k value is 9. They did not ask for the constant of variation right here. They asked for an equation. So we're going to take this k value and drop it into the equation. So our answer for this is going to be y equals 9x. Now, another way that you're going to see this is it's not even going to ask you to find the equation first. Now, we're going to pretend that you went through this process because you remembered it, so you're going to keep with it. So what's going to end up happening is you're going to use this equation right here. And let's make this equation look like ours from up here. And what you end up doing is you're trying to find x. They've given you what the other y is. They've given you what the other x is. Now they're giving you that same line. They're giving you another point. They're giving you the y value, and they want you to find the x. So what you're going to do is you're going to drop this new y value in. Sorry, guys. Problem with owning dogs. So you're going to drop this y value of 63 in, and it becomes 63 equals 9x. Ash, Jax. If y'all wanted to meet my dogs, are here. So we're going to go ahead and divide by 9 and do inverse operations. And you get that x is going to equal 7. Now, if you didn't like that whole process of like substituting it in, having to find the equation first, and that's long drawn out process, then what we're going to do instead is, you remember another way of saying direct variation is that it's proportional? Well, that means that you can set up a proportion using these values right here and not have to do any of this junk just to find an x value. So what you're going to do is set it up as y over x equals y over x. Oops. And we're going to go ahead and replace it with our x and y values. And I was thinking ahead on that last one. So this x value right here, we're going to use it from the original problem. And it said that our x was 8. And our y value was 72. Whew. Now we're going to use this problem right here where it says find x when y is 63. So let's replace that out. And all you're going to end up doing is cross multiplying. So we get 72x equals 63 times 8, which if I did the math right in my head, hopefully, you should get 504. You're going to use inverse operations and divide by 72. And you should still get, again, if Miss Samji did the math right, x equals 7, which is what we got from the equation as well. Again, it doesn't matter which one you're coming from, it still ends up happening. So let's go ahead and look at example 2 and 3, and we're going to check if these tables are proportional. So what we're going to do is find a constant rate of change first, and we're finding our change in x, which you're adding 1, adding 1, adding 1, and then you magically add 4. So don't freak out. Just don't say that it's not linear already. We're going to keep going and check our change in y as well. So we're adding 3, 3, and you're adding 12. So what we're going to do is we're going to set up our change in y over our change in x to see if it actually ends up working out. So 12 divided by 4. So our change in y over our change in x. So it's 12 over 4. And that 12 over 4 simplifies to 3 over 1, which is what we had for all the rest of them. So far it is linear. But now we're going to check if it's going through the origin, which is 0, 0. It doesn't give it to us in our table, so we're going to go backwards. Let me change the color so y'all can see this. When we were going forward, we added 1. We go backwards, we're going to subtract 1, and you get a 0. Same thing here. When we went forward by 3, when we're going to go backwards, we're going to go subtract by 3, which ends up getting us 0, 0 as well. So it does go through the origin, which is 0, 0, which means it's also proportional. And you can do the same process here, but instead of doing all of this work, you'll want to remember that the word proportional in itself gives you a hint. You can set up a proportion. Right here, you can set it up as 1 over 4 equals 2 over 7 and cross multiply to check if they're equal. 1 times 7, well, that gets you 7. And then you get 2 times 4, which gets you 8. And 8 is not equal to 7, so it is not proportional. And it would be something simple, that easy. You could even go back and change this entire one. We could erase all of our work and check it this way. Let's do 2 times 9, which is 18, and 6 times 3, which is also 18. So yes, it is proportional. And it can be something that easy. Remember, this is only asking you if it is proportional. It's not asking you to find it, but you can use the proportion to help you find it as well, like we did in 1B. Example 4, these are going to be very easy to compare if something's proportional or not. If your graph right here is going through the origin, then yes, it's proportional, and because it's already a line. This one, it's a line, but it does not go through the proportion. It does not go through the origin, sorry. So no, it's not proportional. This one, your y-intercept is 0, so yes, it's proportional. Your y-intercept for this one is 3, so it's not. Remember, f of x is another way of saying y equals. But that still doesn't change the fact that our y-intercept is 0, so yes, it is proportional. And in this one, you'll want to recall that y equals 5 is a horizontal line right here. And it's saying that your y-intercept is going to be 5. Your b is 5. Your slope might be 0, and it is a line. But your y-intercept is not 0, so therefore, no, this one is not proportional. Your horizontal lines and your any vertical lines will almost never be a direct variation unless if it goes through 0. So unless if it's x equals 0 as a vertical line going through the origin, or y equals 0 going through the origin, it will not be a direct variation. Thank you again for watching. I will try to post a copy of these really colorful notes to y'all on Google Classroom so that you can watch them along with the notes and you can keep up if you need them. Thank you.